Okay, welcome to the traffic light state machine example. Here I've got 6 LEDs, red, yellow, green, red, yellow, green, each representing a traffic flow direction. So let's call the first one north-south. So right now it's green for north-south. And then the opposite, we'll call the bottom one east-west. And right now it's red for that. They're going to cycle through about every 10 seconds. And as the top one cycles from green to yellow, the opposite will allow traffic to flow in the opposite direction. So over from the microcontroller, which is responsible for the logic of everything, we can just look at 6 of these wires here. We got 2 green ones, 2 yellow ones, and 2 red ones. Each of those responsible for enabling or disabling a pin that connects through a 1 kilo ohm resistor to the positive side of an LED to a conductive rail that all share connection to the common ground. So 6 of these individual jumper cables create a complete circuit for the LED. We might also want to simulate a car approaching an intersection, as in a sensor detecting a car approaching an intersection, or a pedestrian wanting to cross the intersection, so they're pressing the pedestrian button, for example. So if I press this this top button, it would make this top one green, and if I press the bottom one, then it will call it will do it, but it's backwards. There we go. Okay, so the first button changes this to green. The second button changes the bottom one to green. Do it one more time. Green and green. There we go. And in addition to that, the timing is maintained. So we're still we're resetting that 10-second timer every time we get to the green state. All right, states. There are only 4 real states that this system can be in. There's a go state for up here, and there's a go state for down here. That's the green. And then there's the 2 transition states, the yellow transition state here and the yellow transition state here. So the timer and the buttons work together to transition the logic from one state to the next. A bit about connecting this to the breadboard. What's really helpful in these kinds of projects is give yourself the time and the patience to lay things out logically and in an organized way, in a consistent way. There's no real set of rules, but some things that might be useful are, first, here are some example components. Straighten the legs, bend the legs, straighten the legs so that they each easily fit into the same holes per row. So for these 6 resistors, for example, I've straightened the legs, and each of the corresponding pins or legs on the resistor are in the same holes each time I put them onto the breadboard, so that they're consistent. Same with the LED. Most LEDs actually start like this, with a longer leg and a shorter leg. The longer leg almost always being the positive leg. Why not bend them into this kind of hook shape here so that you can easily identify what is the positive leg on the board and easily connect with it as needed. So for these LEDs, the negative leg is always in the same rail together so that they're in a common ground. The positive leg is bent so that I can see that, and when I look at this project, if I'm troubleshooting this project, I can immediately know that if an LED isn't on where it should be on, that at least its polarity is correct.